My name is Evan McNamara, and this is my Phototransistor rotary encoder project. Here is a zoomed-in version of my Phototransistor, and what this device is an IR LED on the bottom here from 1 to 2, and a transistor from 3 to 4 that is capable of detecting reflected photons from this IR LED. Here's the circuit schematic of my device. What I have on the bottom here is VCC, which is 3.3 volts, going across a 100 ohm resistor, which just sets the current to a safe level for that LED in there. On the other side, I also have VCC connected to a 10K resistor, and that goes through the transistor to ground. My V out is measured on the back side of that resistor at A1 on the nucleo. So what happens with this device is that when the sensor sees increasing levels of reflected light from the LED, it increases the current through this device, which actually creates a larger voltage drop across R1, meaning that this V out will go down as reflected light increases. So here's the device I set up to test this, and I have basically a smooth object that can rotate freely, and the sensor is just sitting close to it reading that. I started out by wrapping this device in pieces of paper, and the first one I did was just a paper with black on one side and white on the other to tell if this device could actually tell the difference between these two colors of paper. And I was able to see a significant voltage change between these, so I knew my design was going to be legitimate. I then moved to a piece of paper with different bands of color on it, and this allowed me to see a step function that actually increased the voltage as the color got darker. So I finally decided to go with a spectrum gradient that moves from white to black slowly across the whole thing, so I could potentially tell where I am rotationally based on how much reflected light I'm seeing. So to calibrate this device, I actually did multiple runs at different angles, and I averaged these and plotted them. I was able to find a line of best fit for this data, and I actually found that there was two different significant regions, so I ended up making two lines of best fit, and I coded them both into my nucleo code. So when my nucleo reads the output of this device, it gets a voltage and actually uses those line of best fit equations that I found to predict the angle that the device is at. So you can see that if I turn the device to 90 degrees, the nucleo will register this as right around 90. If I turn it to 180, the device also registers this. And if I turn it to 270 degrees, the device can also recognize this. It does have some trouble recognizing the 0 degree mark because that's the transition from white to black, and it kind of sees the white and the black at the same time and gives a medium value. I expect this device could be used for things like a mechanical robotic surgeon to actually control the angle of the robot's arm.